Welcome to another of my videos where I work through and explain A-level physics multi-choice questions. If you want to try to answer this question, pause the video now. If you got the answer C, very well done. If you'd like to hear my explanation of how I found the answer, please continue watching. So, the graph shows how the maximum kinetic energy, EK max, of photoelectrons emitted from a metal surface varies with the frequency, f, of the incident radiation. P is the intercept on the f-axis and Q is the intercept on the EK axis. Which graph shows the variation of EK max with frequency for a metal with a greater work function? So I'm going to start by looking at the equation for the work function as given on your data sheet. You've got Planck constant multiplied by the frequency, which is the energy of the photon, is equal to the work function, which is the minimum energy to release an electron from the metal surface, plus the maximum kinetic energy that any electron can have. Now, if I look at the graph they've drawn, they've got EK max on the y-axis and frequency on the x-axis. So I'm going to rearrange this equation to make EK max the subject of the formula. So I've got EK max, and that is equal to Planck constant multiplied by the frequency minus the work function. Now, I've got a graph here that's a straight line where y is EK max and x is frequency. So if I look at my equation here, it looks quite like the equation of a straight line. And the general equation of a straight line is y equals mx plus c. So for this particular equation, my y value is EK max, and it is y on the axis. My x is the frequency, and it is on the x-axis. So my gradient m must be the Planck constant, and my y-intercept c must be negative of the work constant, of the work function, I'm sorry. So if I have a metal with a greater work function, then my y-intercept is going to be lower down here. The Planck constant's a constant, that's not going to change, and that's the gradient of the graph. So any graph I produce should have exactly the same gradient. So this is the shape of the graph I'm looking for, something with y-intercept below the Q and an x-intercept to the right of P. Well, A doesn't work, its y-intercept is in the wrong place and its x-intercept is in the wrong place. Q doesn't work, although the y-intercept is lower than Q, which is correct, the gradient has changed and it's still going through P on the x-intercept. C is just right. The x-intercept is now lower than Q, the y-intercept is now to the right of P, and the gradient is the same. We'll have a quick look at D and why that doesn't work. Well, it's got the same y-intercept as the original graph, whereas the y-intercept should be down here with the greater work function. The gradient has changed, which is not possible, and the x-intercept is just to the right of P, which actually is okay, but there's two other faults for this graph. So, correct answer, C. If you found this useful, please press the like button. All comments will be welcome, and I hope you'll share this video and watch more in the series.